Assalamualaikum warahmatullahi wabarakatuh. I am RAYYAN and today's task is I need to complete this assignment question. Determine the force in each of the members of the truss shown. State whether each member is in tension or compression. Let's take a look at the question. So what I'm gonna do, I'm gonna find moment I to find force for member E and F. Let's solve. As you can see, I get the answer of negative 15 kilonewton, and since it's negative, we're gonna assume it as compressed. Now, if we look closely to the triangle, joint F is actually at the middle of the triangle, so we can find 2.5 meter height, and joint H is actually the middle of the other triangle. So half of 2.5 meter is 1.25 meter, and base is 3 meters as the question shown, and we can find the hypotenuse using Pythagoras theorem. Now we can solve GH and HI. Let's solve using this way, and I get my answer as negative 26 kilonewton compressed for HI and 11.54 kilonewton tensile for GH. Let's find other members. If we take a closer look, EGHI is actually an equilateral triangle, so that means HI is equal to HE, but instead of negative, it will be positive because if we find the moment on G, it will be the other way around. Not to mention that EFH also an equilateral triangle, so that means they're also gonna have the same answer as tensile. That is all for my part. I will pass it down to my other teammate. Thank you.
Assalamualaikum and greeting. My name is Muhammad AZIQ. Right now, I'm going to solve question number 1, set 4. So I would like to find A and B first before find other members. First of all, we need to draw free body diagram to make us more clearly understand about the structure. Here my free body diagram. As we can see, at point A, it have two direction. It have two direction because A is pins. Meanwhile, B have only one direction because B is roller. To find A and B, we need to set I as moment point. So here is my equation for moment point I. As you can see, there are two unknown force, but don't worry, we can find AY first. To find AY, we need to summary FY to equilibrium. So AY got 40 kN, but it's up. Direction, the direction is up top. So after we got AY, we're gonna put AY into the moment equation back. As you can see, our AY got negative because it's opposite direction of moments. And BS, we got 60 kN. Also, don't forget that we need to find AL also at point A, because at point A there are two reactions. So AX will get 60 kN. To free body diagram, to find the height of each member, we need to divide 5 with 2. So it's gonna be 2.5 meters. So to get h, we divide also. We divide and we got 1.25 meter. Here we focus on joint B because if we focus joint H, it's difficult because there are many angles. So as usually, we draw a small FBD, and then the triangle trigonometry. Let's see FBD. So if we extend this and this, so we will get 3m, and this one 1.25 m. So this will get 13 over 4. So back to the question. First we need to find summary of fx, because at the point B we only have bs only. This code is further. So we focus. We do a equation 60 plus FBD triangle equal to 0, and we will get FBD equal to negative 65 kN. So in the FBD we assume that it's tension, but in the equation it compress. So after we get this, we gonna make an equation for Fy. So we make equation, we will get FAB equal to negative 25 kN. So our assume is wrong. So in the equation it's 25 kN tension. So now we focus at point A, joint A. As usually, draw FBD and find the triangle for AD. So first thing, we need to make equation for Fy, summary Fy. So we get 40 minus 25 minus FAD. So in this question we need to find FAD. So our FAD will get 19.2 kN, and it tension. So the assumption is same with the equation. So now we focus fx. Fx negative 60 plus 19.2. So 19.2 is from FAD, and triangle plus FAC. So in this question we need to find FAC. So our FAC will get 48 kN, and it tension. So our assumption is true with same with equation. Let's focus on joint D. First we need to find DF first, because there are only one unknown there. So we're gonna put a equation, fx equation, and our FDF we got 52 kN, and it's compression, because in here we assume it's compressed. So next is we're gonna find FCD. So we use the equation Fy, summary Fy, and we do equation, and we got 20 kN, and it compress. It's same like we assume. The drawing C, we gonna find FCF first, because there are only one unknown. So yeah, let's use summary equation for Fy, and we got 15.6 kN, and it tension like our assumption. So here the triangle for CF. To find CE, we use FL equation, and we will get FCE equal to minus 36 kN. So our assumption is compressed, but in the equation it will be tension, so the value is negative. So that's all from me. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. So today I, Wan Muhammad Asif, will discuss about this question. So question number 2. As shown, determine the reaction at A, D and E. After that, we determine all the force at B, C and F. So first thing, we must draw the free body diagram. After that, we must find total moment at B, total moment at E, and then we can find F. So for total moment of B, we can see we can get FCD multiplied by sine theta times 1.5, the distance with negative minus 800 multiplied by 2. So then we find FCD equal to 1922.69. So by Y, so the total is 266.67 Newton. Then we find the total moment for E. So total moment is negative Bx multiplied by 2 plus 266.67 multiplied by 1.5 and plus 800 multiplied by 1.5. So we can get the Bx equal to 800 Newton. So we can get the total of Fx is equal to 0. So we can find the total of Fy also, that is 266.67 Newton. After that, we can find Ax using the Fx equal to 0, summation of Fx. So Ax is plus 800 minus 800 plus 192, plus 1922.96 multiplied by 2 over square root of 13. So we can get Ax is equal to 1066.67 Newton. So we already find A. After that, we find D. With the same step, we find total moment at D. So we can get the dx is equal to 355.56 Newton. Next, we find C. On C, we just use Fy equal to 0, summation of Fy. So then we can get Cy. So Cy is 1066.67 Newton. And lastly, from that all, we can find F using summation of Fx equal to 0 equal to Fx minus 800 plus 1922.96 multiplied by 2 over square root of 13 plus 800 and 800. So we can get Fx equal to 1866.67 Newton. So that's all for me. Thank you.
My name is Muhammad Nazif bin Abdul Latif, and today I will be explaining question 3 from set 4. The question is, in using the bolt cutter shown, a worker applies two 300 Newton force to the handles. Determine the magnitude of the forces exerted by the cutter on the bolt. This means we will have to find the force that is exerted by the cutter on the bolt, which is here. I have drawn for the each section of the bolt cutter, and we will be completing the free body diagram. From the perspective of the bolt cutter, we could make it in half, and this will determine that the C point here is like a pin support, which means it doesn't move. And so we could determine the BYD, which is 300, is moving down, and because C is a pin support, we could determine that C is above. CY, and then it should be here, which is CX. And then B should be the opposite, which is here, BX, and then BY. because the B point here is connected, here and here is connected, it should be the opposite. For example, like BY is moving down, this here should be moving up. And BS. The AY here should be only moving down, opposite for the here. Yes, AY and also AY. And this is the force that we will want to find. Moving on, we now should be able to find the EOE of every section. We will first complete for the section of A and B. Fs equals to 0, which is, there is only one, which is Bs. And then Fy equals to 0. We know both By and negative Ay. But we do not know any value, so we will move on to the moment. Moment we will take from point A, and such we will put in the values, which is By equals to in 96 millimeters, which is the distance between By and A, minus F 24 millimeters. Okay, 96 By equals to 24 F. Oops, and with this we get F equals to 4 By. Moving on to the next session, because there is a lot of unknown X and Y, we will speed it up to the moment. We will be focusing on the moment equation, and we will take it from the C point. Which has, because it is from C, we will have By, Bs, and the 300 Newton force. As such, Bs is 24, the distance from the midpoint, plus By, which is 12 millimeters in distance, and minus 300 Newton, with 448 millimeters in distance. 400 we will get from 450 minus 12, because this is B, and this is C, and this is the 301. The full length is 400 and 460.
while the middle here is only 12. So this will be 448. And moving on to the equation, this is equal to 0. And we know that Bx is here, which is equal to 0. And so 0 times 24, which is 0 plus 12by, and we will take the 300 and put on the other side, which will be equals to 1,134,400 Newton. And simplify the equation, we will get By equals to 11,200 Newton. This will be the equation of number 2. We will now put the equation number 2 into 1, which is this number 2, and this is number 1. Because we want to find the force that is applied to the bolt. And so, which is, what F equals to 4By, which is like up here 11,200 Newton, which will result in 44,800 Newton, or 44.8 kilonewton. Thank you very much.